Incidentia Brief is back with today's cybersecurity analysis. Today we're looking at an industrial control vulnerability in Rockwell Automation's Flex 5000 adapter. It's rated as a denial-of-service bug, and on paper that sounds minor. But in operational technology, a denial of service can mean a production line goes dark and stays dark. We're going to challenge the instinct to dismiss this one. Picture a manufacturing line running as normal. Then, in an instant, a control module stops responding. The attached input and output devices go offline with it. Operators reach for a remote reboot. Nothing happens. The module will not come back over the network. To restore it, someone has to physically walk onto the plant floor and power cycle the hardware by hand. That scenario is the heart of this story. So let's start with the confirmed facts. The flaw is tracked as CVE 2026-12659. It was published in a CISA advisory, ISA 26-197-08, on July 16, 2026. Rockwell issued its own advisory, SD 1789, 2 days earlier, on July 14, 2026. The affected product is the Flex 5000 adapter, version 6.0.11. According to CISA, the problem is improper handling of exceptional conditions when the adapter processes crafted CIP packets. CIP is the common industrial protocol, the language these devices use to talk to each other. Send the right malformed packet, and the module faults. Here's the critical detail. Recovery requires a power cycle. The module and its associated I/O will not restore themselves. There is no remote reset. That single fact changes everything about how you should read this bug. Now look at the scoring. This vulnerability carries a CVSS version 3. 1 score of 7.5, but under CVSS version 4.0 it climbs to 8.7. Same flaw, 2 different numbers. That gap is not a mistake. It tells you something important. The 7.5 is driven by the technical profile. The attack vector is network. Attack complexity is low. No privileges are required. No user interaction is needed. And the impact is strictly on availability. In other words, an unauthenticated attacker, reachable over the network, can knock the device offline with one packet. No credentials, no clicking, nothing. So why does the newer scoring model push it higher? Because CVSS version 4.0 does a better job of capturing recovery cost and operational context. In classic IT, a denial of service is often a brief outage. You reboot, you move on. But this is operational technology. The recovery here is not automatic. It's gated by a human being physically traveling to the plant floor. That's the real risk driver. Your mean time to recover is not measured in the seconds a remote reboot takes. It's measured in how long it takes a technician to reach the equipment, whether it's the middle of the night, a remote site, or a facility with restricted access. An attacker can trigger the fault remotely and repeatedly, but you can only fix it locally by hand. This is why a plain 7.5 undersells the practitioner's reality. The CVSS number describes the attack. It doesn't fully describe the pain of getting back online. In an environment where uptime is the whole point, a repeatable, remotely triggered outage that demands physical intervention is a serious operational problem. Now, let's be honest about what we don't fully know. Some reporting classifies the underlying weakness as CWE 415, a double-free condition. That detail is single source and unconfirmed, so treat it as a plausible explanation rather than settled fact. Rockwell reportedly found the issue internally during routine testing and disclosed it under a transparency commitment. That origin story is also unconfirmed. There are also unconfirmed reports that engineering workstations running Studio 5000, RS Logics, or RS Links Classic communicate over CIP, meaning a compromised PC on the network could craft malicious packets against these adapters. That's a reasonable concern, but it's single source, so verify it in your own environment. As of disclosure, there's reportedly no evidence of exploitation in the wild, and it is not listed in the known exploited vulnerabilities catalog. One more note, these advisory dates fall in 2026, which postdates some reference baselines. If you're acting on this, confirm the current advisory details directly with CISA and Rockwell before you build a plan around them. So what do you actually do? First patch, Rockwell says the fix is upgrading the Flex 5000 adapter to version 6.0.12. That is the only true remediation. Crucially, there is no remote workaround. You cannot configure your way out of this one. Until you can patch, segmentation is your interim control. Isolate the CIP-exposed adapters. Limit which systems can reach them over the network. Reducing who can send a CIP packet to these devices directly shrinks the attack surface for this flaw. And here's the step people overlook. Pre-plan your physical recovery access, because if this is triggered, the clock starts the moment the module faults, and it doesn't stop until someone is standing in front of the hardware. Know who that person is. Know how fast they can get there. That's the difference between a short blip and a long outage. So let's bring it back to where we started. A line goes dark. The remote reboot does nothing. The question that decides your downtime isn't the CVSS score. It's simpler and more human than that. Who drives to the plant? Answer that before an attacker forces you to. That's the analysis for today. Stay measured, stay patched, and I'll see you in the next brief.